This is a presentation on data flow diagram. This is by Jonathan Roberts and Michelle Markham. Let's jump right in.
Every program or application deals with the transformation of data. That data starts somewhere, and after going through one or more processes, an output is produced, and that output also has to go somewhere. A data flow diagram helps break down the functionality of a program by focusing on its inputs and outputs. Data flow diagrams are an excellent tool to use for planning out the details of even the most complex program. By using a limited number of symbols and simple rules, a program is broken down in a hierarchical manner. The methodical process used by data flow diagrams actually helps the human mind overcome cognitive limitations experienced when trying to understand complex systems. Since there are so few symbols to define a DFD, interpretation is fairly easy, even if the actual graphics vary among users. This makes the use of DFDs a great universal tool. There are 4 basic symbols to the DFD. First, we have an external entity, which is something that provides inputs to the system. This can be a user, a database, a file, or even another program or software. Data flow inputs and outputs exist between the application and one or more external entities. Then we have a process, and a process is something that transforms data in some way. It can have one or more inputs and outputs. Next, a data store represents data at rest. It can be a database, file, or other location where data can be stored and retrieved from. Data can be written or read from a data store. Store is generally internal to an application, but on occasion may be also represented as an external entity in a level 0 diagram. Lastly, we have our data flows. Data flows are shown using the direction of the arrow. Input and outputs are drawn separately, not combined into a bidirectional arrow, although they may be combined and forked off in the case of an output that may feed into one or more location. A level 0 or context level diagram is the most abstract DFD. It can be seen as a bird's eye view of a program. This is always the first diagram created. There's only one possible version of this diagram. It contains all external entities. What this means is that subsequent levels cannot contain any additional entities than would be identified here. There's also only one process. This process should summarize the main function of your program. Data stores are not represented at this level since they are internal to the program. Although in some cases, a data store may also be an external entity. In such a case, the data store is shown as an external entity in the level 0 diagram. A level 1 diagram is the first step in decomposing the process shown in level 0. There is only one possible version of this diagram. Having more than 7 processes at any level will make your diagram too complex. So, in level 1, using the SRS as a guide, you would group the high-level functions of the program into 5 to 7 processes, each having inputs and outputs. Each process identified in the level 1 diagram is broken down or decomposed into subsequent levels. Thus, while there is only one level 0 and level 1 diagram, you will have many level 2, 3, 4, etc. diagrams. Each diagram representing a further breakdown of the previous into subfunctions and their inputs and outputs. Decomposition of a process is stopped when you reach redundancies.
As you can imagine, there are many advantages to using a data flow diagram. One of the most important is that it is easy to understand. This is because the processes are described in general terms and the arrows going in and out are easy to follow. There are only a few symbols that are easy to recognize, and a data flow diagram is really good when communicating an existing system to show what is happening. Even though it is easy to understand and simple in many ways, it can still be very detailed and can show lots of different processes happening, especially as you go through the different levels. And a data flow diagram is also very good for non-technical users because of its simplicity. There are not many downsides of using a data flow diagram, but there are some disadvantages that we can discuss. One important disadvantage is that it can take a long time to complete, and because of the length of time, it is often skipped over. To skip over it is usually a mistake, but because it does take so long, it happens. The physical systems are left out of a data flow diagram. They're not expected to be considered, but it is worth noting that they are left out. And the final disadvantage is that a data flow diagram organizes the processes in a way that are not necessarily easy to translate into an object-oriented language into the objects. So the diagram on the side shows how a data flow diagram would decompose a system into loans, resources, and fines. But when you do it in a language of objects and object-oriented approach, it would come out with catalogs, books, library, and librarian. A different way of looking at it, but that doesn't mean that it's not worth doing the data flow diagram. Just worth noting that it comes out differently when doing it in classes. So what would the data flow diagram look like on the HACC application? Well, to do this, we decided to look at the level 0 or context diagram. And the reason we did this is because when we tried to go deeper on a level 1 or level 2 diagram, we found there were too many questions and we needed to make sure that everyone that was on the same page on a level 0 context diagram first, and then we can go deeper. So looking at the context diagram, we have the HACC process system in the middle where all the work is being done, and we found two entities, the student and the LMS entity. We debated if there's a third entity for security, and there still might be. It has a lot to do with how the HACC application is integrated into iLearn with BYU Idaho, something that we think merits further discussion. So on the student side, it has a lot of ways of interacting, particularly sending data to the HACC application. It does this by creating manual assignments, creating tasks, by updating manual assignments, or if it's an LMS assignment, to update its status, and to update tasks. And what a student receives back is the display of either the homework, the course, instructor. All those displays are what are being passed back to the student. On the LMS side, there are two primary interactions. The first is HACC needs to know about any changes to courses and assignments. So the application will be requesting every 10 minutes to see if there are any changes, and then coming back, it will return those course and assignment changes if there are any. On the student side, after a student comes in, if it is an LMS assignment, the student's assignment info will be requested from LMS, and that LMS will return their assignments. Thank you for watching. I hope you learned something about the data flow diagram.